Hi, here in this question we are given that ABCD is a regular hexagon with each side 1. So we have a regular hexagon. Let's say this is a regular hexagon and each side is 1. The area of a square with AC as one of its side is how much? Okay, so let's say this is A, B, C, D, E and F. So we have to figure out the area of a square with side AC. So area of a square is basically square of its side. So we just have to calculate the value of AC, what will be the length of AC, and square of it will give us the area of the square. Now if you look at this triangle here, this angle is 120, right? Internal angle of a regular hexagon is 120 and this side is equal to this side. So this angle will be 30 and this angle will be 30. Now in fact, if you remember, the distance between the two parallel sides, I was actually trying to derive it, but if you remember directly, we'll derive it also, but if you remember directly, the distance between two parallel sides of a regular hexagon is √3 times the side, right? This is standard in a regular hexagon. Distance between two parallel sides FA and DC are parallel to each other. So the distance between A and C is √3 times the side. Side is 1. So AC will be √3 into 1, √3. Let's derive it also. How can you derive it? So if this is 120, this is 30, this is 30. And internal angle this also is 120. So 120 minus 30 is 90. So these two angles are effectively 90, right? Now if this is the center of the hexagon, so let's join center O with CD and FA. Now we know if you join the center with all the three or all the 6 vertices, let's join all the 6 vertices, we get 6 equilateral triangles. These are all 6 equilateral triangles, and since we have to calculate, since this is 90 and this is 90, that means we have to calculate the perpendicular distance between A and C. The FA and DC are parallel to each other. We have to calculate the distance between the two parallel sides. So that can also be calculated if we draw this line here. So the length of this line is also same as length of AC. Now if you consider this equilateral triangle here, in this equilateral triangle the 3 sides are equal to 1 and this part is the altitude of an equilateral triangle, and we know altitude of an equilateral triangle is √3 by 2 times the side, which is 1. So length of this part is √3 by 2, length of this part is also √3 by 2. So √3 by 2 plus √3 by 2 together is √3. So the length of this whole side is √3, right? So if length of AC is √3, square of AC will be √3 square, which is 3. And this will be area of the square. If you draw a square with side AC as one of its sides, and the other will be, let's say, some EF, not E, let's say H and I. So if this is a square, one side is √3, the other side will also be √3, right? So √3 into √3, area of the square is √3 square 3, which is option B. Thank you.